All right, so it is 1 o'clock, so we'll go ahead and get started. Thanks everyone for joining. Today we will be discussing tags and performance. It's one of a few different webinars in our tag performance series. Today we'll be going through some learnings from the Internet Retailer 1000 sites. Ran some tag inspector scans across all those different sites. Just want to go through what it is, exactly how tags impact performance, some findings for some low-hanging fruit from those sites, and then how you can apply it to the work that you're doing and the sites that you're working with currently. To get our general housekeeping out of the way, just about Tag Inspector and your presenter, obviously, as all of these webinars, it's brought to you by Tag Inspector. As many of you know, Tag Inspector is a product of InfoTrust LLC. On the InfoTrust side of things, we do web analytics, tag management, and consulting work, as well as product development, one of those products becoming Tag Inspector. On an annual basis, working with several thousand sites, we do a large number of training programs each year, including these webinars. We have offices here in the US, Cincinnati, as well as in Dubai. Your presenter, that is me, Lucas. I am our product manager on the Tag Inspector side, as well as a tag management consultant, working with a lot of our clients on troubleshooting and optimizing tag deployments using Tag Inspector, as well as just general management and optimization of tags on their websites. Just to get into the just high-level agenda, not a whole lot of different sections, I guess, today. I want to go through first a performance overview. So just to recap, as some of you might be familiar, I think a lot of you might be good to get a refresh, just an overview of how everything works with the web page, with the website, how tags play into that. And then I want to touch on some common performance issues due to tags. So why tags and how tags affect those different aspects, as well as what to look for. Once we go through those basics and that overview for performance, I want to get into some of the findings that we have from the Internet Retailer 1000 scans. And these will relate back to, again, how tags are factoring into sites. And then we want to spend some time looking at how we can actually address and optimize those different things. So go through an overview, how it works, why it's important to figure out what sorts of issues are present currently on some of these top retail websites and areas to look at on your site, and then how we can actually go in and address them. At the end, we'll wrap up with questions. As always, feel free to drop questions, shoot them our way throughout. Happy to elaborate on anything that is needed to elaborate on at that time and answer any questions along the way. So use that question pane within the GoToWebinar interface there. You should have a little box. Drop questions there, shoot them over to us. We can answer them along the way. Perfect. So to jump into it, and this is real high level for just how it works. And this is referring to how your website is working, how the internet in general is working. So first thing here on the left side, you have a user, call her Mary. Mary comes to the website, enters in the web address. First thing that happens is your browser is going to send a request to the server where the actual content of the site or the page source, the code for your site is sitting. So that request goes there, that server returns the actual code. What then happens is your browser is going to parse through that code as if it's reading it. So it goes top to bottom. And it's going to execute any of the commands or the code that are there, as well as read and execute any additional code. So in the context of tags, your other JavaScript that is on that page. Now, as the browser goes through that, it's going to be sending requests to other servers. First, your site server, wherever your content, images, all that information sits, to be able to return and actually build out the user interface or the front end, what the user is seeing on your web page. In addition, any tags that are executed, those requests get sent to those different respective servers, where they might be returning additional JavaScript or returning some sort of a status and collecting data on your users. collecting information about the website, whatever the function of that particular tag or platform is. So summarize here, browser sends a request up to a server, brings back the actual code of the page. All of that gets executed. Additional requests are sent out to other servers that house the data that actually makes up the content of the website, as well as any third-party tags that are functioning. And one by one, those things are also returned to the browser. On the browser end, it's then piecing together all those bits of information and actually displaying the content of the web page, as well as sending off and executing any requests in the background in order to be able to do whatever the different third parties are wanting to do on that web page. So in terms of a tag, this is an example. So this is just in that red box there is an example of a Google Tag Manager tag snippet. What that is just JavaScript that as the browser goes through, parses and reads through that code, it's going to execute that. What will happen here is a request. Think of one of these servers to say that one in the bottom left. The browser reads that code that we just looked at on that previous page, sends that request out to, in this case, GTM or Google Tag Manager. Google Tag Manager has a server, and that is then going to load into the browser the configuration for that container, since Google Tag Manager is a tag management system. Now, within that configuration, obviously, contains all of the other tags that you're managing within GTM. Those then get loaded in to the browser, and the browser begins parsing through and reading and executing each of those codes. When each of those executes in the browser, those requests are then sent to its respective server. So it might be Google Analytics, it might be Criteo, it might be Facebook, it might be Twitter. They're all going to different respective areas, typically with information that script has built, either on user information, cookie information, content information on the website. It's going back to those servers. They take them, it processes that information, and out then on the other end kicks the nice reporting and nice functionality that you see within those different tools. At the same time, response is sent back to the browser saying, yep, we're good, we got it, and all is well. So a lot is happening here in order to, one, display any sort of content on your website, as well as to collect any information for things like analytics or advertising or media platforms. How all that's working, and some of the things that you've heard me referencing, are requests. So the browser executes a request or sends a request for a image, content, tag, whatever it may be. What all of these look like within the browser, you can see within your network tab, if you're familiar with development tools or dev tools in your browser, and anyone can use these. If you open, typically all you have to do is right-click. If you're using Chrome, right-click, go to Inspect Page or Inspect Element. In that drop-down, up is going to pop your actual development console here. There will be little tabs. You can tab over to Network, click on that, refresh the page. Then what you're going to see is all of the different requests that are being sent by the browser in that particular instance or on that page load. So these requests are what is being sent by the browser due to the scripts or the page source and the other different tags and scripts that are embedded within there. So we can see there's a ton of activity. All these things are being sent. Once they get to the respective platform, respective server, something has to be done. It's either collecting information that's contained within these requests, or it's taking the request that's made by these different network requests and returning something more for the browser to do. An easy way, and how I like to at least think about this entire process and just to kind of simplify it down, is you have three different areas. And we'll break out the things that move the dial and move the needle within each area when it comes to overall site performance. But you have the client, which is the actual browser that is loading the website, piecing all the different pieces together, sending off the requests, receiving the requests, and then building everything. So that's like your Chrome, what your user is using to access your website. You then have the connection, or like the pipes, so basically the internet. So the mechanism through which the client is sending those requests and how those are then getting to the individual platform server in the context of a tag, or the server that your actual site content and images and everything are sitting on in the context of your website content. So you have your connection or your pipe, your client, and then you have the server end. That's on the third party end. That's where the request comes in. It then executes and does whatever is being requested, and then we'll send a response back along through that same connection or through that same pipe back to the client. I always like to encourage people when it comes to site or page performance and user experience. A great experience is the result of doing a lot of other things really well. So you can't just go into it, oh, I'm going to optimize page performance. I'm going to optimize my tag deployment in order to be able to optimize my page performance. Well, no, great page performance is the result of doing a lot of other smaller things really well. In the context of tags, it's better managing your tags, cleaning everything up, keeping everything current, as well as managing the number of requests, the size of those requests, and the different aspects that we'll get into here. So in that same line of thought, we need to be able to optimize different little aspects. So I want to just go through each of those different pieces of the puzzle. So the different players and factors that are in the game when it comes to there are factors in the performance of your website. So first, you have the client, so the browser type, and some of the limitations here in how and why your user experience can be not as good due to some of the limitations of the client. So first you have CPU. So this is just how much can the machine handle, any sort of processing time and effort. Happens to me all the time, happened to me just before this webinar. I just have too much going on my computer. It's using up too much memory. Too much is trying to happen, so everything slows down. That can happen also on your individual website. If you're trying to execute a lot of things, if the browser's trying to do a whole lot of things and it's taking a lot of CPU from the computer, that's going to slow down everything that's happening on your user's machine, which as a result is going to have a negative impact on their user experience. So think about the processing time, effort that the machine's going to take in order to be able to execute a lot of these different requests, run the functions, and everything that's on your website. Number two, just general browser limitations. So we talked about before how those requests get sent. So they get sent from the client, they get sent to the respective server, and then returned. So there's limits to how many outstanding requests a browser can have at one time. So one thing when you're talking with tag vendors, they'll always say, oh, our tag load's asynchronous. It's not going to block anything. It's fine. It's not going to have a performance impact. In many cases, it is going to be asynchronous, but we have to keep in mind browser limitations even for asynchronous or concurrent or parallel side-by-side, things that can run at the same time. So thanks to the same host name, it's going to depend upon the browser. It'll be like the same domain, it requests to the same platform, basically. But typically, in a browser, it's going to range between 6 to 12 concurrent requests. So say in the case of a global organization, you've got a bunch of different sites that each one has their own unique analytics property, right? So say you're using Google Analytics. If, for example, there might be a lot of overlap in teams, each team wants to have their own property or place or account within Google Analytics. So everyone wants to put their own Google Analytics tags on the website. there's only going to be, just due to browser limitation, let's say you have 15 individual Google Analytics properties configured on there. Each one is going to want to be sending its own request to its own property, just so that each property can collect that information. A browser at one time is going to not be able to handle all of those requests simultaneously. So because to the same host name, between 6 and 12. Beyond that, there's also limitations in the browser for the total number of concurrent connections that can be out there at one time. It varies again by browser. Typically, this ranges between about 14 to 17 for current browsers. So again, we're looking at a limitation based, if you have a whole lot of requests, and those requests include those requests that are going out to your own servers or to your content delivery network for images that need to be displayed on the website or for content that needs to be displayed on the website. Factor those things in along with the tag requests. Only 14 to 17 can run at one time, can be outstanding at one time, even if they are asynchronous and not going to, by their nature, block everything else from happening. They can, in aggregate, act as a clog, basically. So other requests cannot be sent, other things can't be executed, which is going to slow down the process of your page in general, just being able to be loaded. Final piece here on the client end is just your site code itself. How much is there? How complicated is it to run? The client is going through, or your browser is going through, reading through that code. So in order to be able to execute everything, if you have a really long page, it's going to, just by nature, take longer for it to read through it. It's also, and one thing we'll touch on a little bit later, location and the depth of your different tags matters. If you have a really long page, a lot of line numbers in that code, and some of your critical tags are way down at the bottom, it's going to take a while for those different things to be executed. Then if you have a whole lot of requests, so your browser is running up against the limit for what can be sent and received at the same time, those things are going to be delayed even more, and you're running a chance of a user accessing a page, leaving that page before critical platforms, critical tags are able to execute, run their function, and collect any sort of information. We'll get into that a little bit more here in a bit. The second piece of this puzzle here is the actual connection, or the pipe. The biggest thing you want to keep in mind here is bandwidth, the internet connection, right? So you can think of bandwidth as like the size of the pipe, how wide, how much time, or how much can the internet connection handle at once. So you have your browser limitation, but then you also have your connection limitation. There's only so much data that can be sent and received and go through that pipe at one time, depending upon how fast or how slow or how much capacity that user has on their internet connection. So we need to keep in mind when we're thinking about page size, and the proportion of that page size is made up by files that need to be sent and received by our third-party tags. That contributes to page size. The larger the size, the more drain it's going to take on bandwidth, the more bandwidth that's necessary in order for, even in a vacuum, for that page to be loaded, just because the information, the data needs to be sent and received. Another thing to keep in mind here, distance traveled, it's minor, but we do have to realize that the internet is literally a bunch of wires and satellites, I guess. But while small, location does matter. If you're working with different types of third-party platforms and they're serving, their servers for their tags are all the way across the world, it's going to take, yes, milliseconds, but more time for those requests to reach those servers and then come back and reach the client or the browser of the individual user. That time adds up. It adds to latency numbers for the actual tag itself, for the tag latency, and it can slow down not only the load of your web page, but also potentially the load of other tags. And then finally here, just connection speed. How quickly can our requests, excuse me, and our responses travel? How quickly can the request make it from the browser to the server and then back again. Again, compounded with these other items and limitations, and has an effect. Has an effect on page performance. It has an effect on the effectiveness to which you're able to collect information. The last piece here is on the server end. So where those requests are going, these would be the servers maintained by those different third parties, or say your content delivery network, CDN. You have to think about latency, which is the time for the server to begin a response. Processing time, how long is it taking on that server end for that processing to happen, which then factors into latency. And again, location. How far does that request have to make it? How far does that response have to make it in order for that full request process to complete? Biggest thing to keep in mind about these three items here is it plays into and it compounds the issue that we touched on with the client, where we can only have so many outstanding requests out there at one time. Once I hit that limit, the browser can't send any more. So it is, in effect, even if they're able to run side by side, it is, in effect, blocking that connection, blocking that highway, so nothing else can happen. No other content can be sent, received, including, like I mentioned, page information. So we need to keep all these different factors in mind. We need to optimize for each of these, as we'll see, in order to be able to optimize tag performance as well as individual page and site performance. So that's the basics of how just a general website works, how we're sending, receiving, how we're getting that content, how we're displaying it, how our users are accessing the information that's out there everywhere in the cloud. So how do tags play in? Tags are executed, again, going back to the JavaScript, executed by the client. They're sent, the requests and responses are sent and received through the connection, the pipe, and the actual processing and everything's happening on the server end by that third party. So the server's where the data is going, where the response is coming back from, all that's happening there, and it all plays together. So things that we really need to think about when it comes to tags and optimizing the performance of our site, as well as the performance of our tag deployment and the performance of our data collection apparatus. We need to keep these different aspects in mind about the tags to be able to optimize. So one, thinking about tags, and I threw the term around, didn't really define it, but synchronous versus asynchronous. An asynchronous tag, as I mentioned, or an asynchronous request, more than one can happen in parallel. With a synchronous request, it's the only thing that can be executed at that time. Now, most tags now, most pixels now are asynchronous in nature, but depending on the platform, especially if you're working with like an A/B testing platform, for example, those still run synchronously. And it makes sense for an A/B testing. If you're testing page content, it's got to block the content from loading before it's able to then serve in and tell the browser what content to load. So need to keep in mind synchronous versus asynchronous. If it is a synchronously loading tag, and if its latency is high, it is blocking everything else on that page from happening until it is completely finished running. So if latency of a particular tag that's synchronous is taking 2 seconds, that's basically the start point. You're never going to have a page load or your content in there, DOM complete, first paint, whatever it is that you're really optimizing to for page performance. It's never going to happen until after that synchronous tag happens or is complete loading. Asynchronous, we just need to keep in mind the other limitations. Some of those that we need to look at for tags: request size and volume. Again, the bandwidth implications. If we're running up the size of the page, running up how much data needs to be sent and received from the client and the server side within those middle pipes, due to size of tags, size of pixels, we are taking up a lot of the resources that are available to be used. Where we see this really come into play is with piggybacking and daisy chaining of tags. So you've maybe implemented something on your website, either directly through the code, through the tag management system. Oh, just one more platform, it's okay. You vetted that tag, you looked, okay, 1, 2 requests, decent size, latency figures are good. But then it starts piggybacking in or loading in other tags on the back of it. So now, things that you didn't potentially personally or your team didn't implement on the website, now there's other things loading. So one, it's a concern for data leakage, just leakage going to third parties that are maybe unauthorized to be collecting that information. But two, it's more requests, it's more tags that are loading on the site, more things that can be going wrong, as well as adding to request size, the volume of requests on that page, more resources for the browser to have to handle, more resources for the that have to travel through that connection or those pipes. It's slowing down other tags as well as potentially slowing down the actual web page performance. Third thing here is just the general nature of requests. Different tags, there's different types, different functions, but the key difference here is there's differences in how much processing is required from the browser end. I mean, think about it. If you have just an image pixel, going back to the days of just analytics and everything being just counts. So every single time browser runs through it, it just counts, sends a static request, executes a static request, one server, super quick, boom, returns a clear one by one pixel. That, hardly any processing, nothing really involved. Other tags, though, it might be loading in a second JavaScript library that then has to run, your client, the browser has to run that in order to be able to then collect other data points on the page and then create another request, send that up, maybe return something different, something else has to run. You get the point. There can be a lot more processing necessary for different types of tags, more CPU that is required from the user's machine, which again is going to be pulling down resources and slowing down the performance of the page, as well as delaying and slowing down the execution, the effectiveness of some of the other tags and pixels on the website. Final thing here to keep in mind with tags when it comes to performance is the latency of vendor servers. We don't want requests being outstanding for a really long time due to poor latency on the vendor end. And again, that's just because it's outstanding requests. Your browser can only handle so many. So if they take a while, it's going to slow down everything. Think about it as you're driving down the highway, pretty good amount of traffic, have a couple of people, speed limit 65, a couple of people in front of you going 45, it's going to slow things down for everyone else that's trying to get through there. Same idea here for the requests and responses that are needing to be sent. We kind of touched on this, but just to reiterate, sync versus async, again, synchronous can block page content, tag requests, the use of the resources, both in the browser end, as well as CPU, being able to having the effect of clogging those pipes, if you will. Latency of vendor servers, just touched on. And then again, location matters. And I really want to drive this home. The page source is parsed, the code on the page is parsed or read from top to bottom. So the lower in that a particular tag is loading, the later it is to go into the queue in order of being sent, in order of being executed by the browser. The biggest implication here, it's not necessarily on the performance of your web page, because if it's an asynchronous loading tag, your page content might already been loaded. But for key platforms, so say your analytics platform, that you're investing between the platform, the team, all the resources and everything that are going into it, a lot of organizations are investing upwards of 500, 700, or even 700,000 or even $1 million a year in an analytics platform. And just because it's loading really low down in the page, you have data loss implications. A user comes to that web page and leaves before that tag can execute. You're not collecting information and the data points for that particular user. So you're going to have huge discrepancies between, say, like your backend's e-commerce system and what you're seeing for transaction information inside of your web analytics platform. This same issue is compounded by bad behavior of other tags. If you have a whole lot of requests, it's taking a lot longer, even if it's in the queue because it's been read and parsed. It's taking a lot longer for it to be able to get up there and actually executed by the browser. So we want to, as we think about tag management in general and optimizing deployment, we want to rank basically our tags. What are things that are most important? What needs to be loaded higher in a web page so that we don't run into any of those potential sorts of issues? Which brings us to kind of the point, right? So what are those little things that we need to optimize? What do we need to look at with our current tag deployment in order to be able to improve performance of the website? And then how do tags play into that? So one, page size. If you're the development team or the performance team, you obviously can control, and you're always working to optimize page size and just page performance in general. In the context of tags, we can look at what is our goal? What is the goal for page size based upon limitations of browsers and what types of devices and connections our browsers or our users are typically using from a bandwidth standpoint. Looking at that in just a vacuum, we can see a maximum size of a page if we want that page to load in X number of seconds. Once we determine that, we can then start looking at what proportion of that is tags, is made up by tags. Do we need to be removing things just in order to be able to hit our theoretical best possible performance number for the page? So page size matters, size of the tags factors into that. Also request size and volume. Again, processing required for the different requests, the clogging of the tubes that I had mentioned previously with different requests and everything clogging up that connection, and the limitations of the browser to only have 14 to 17 outstanding requests at one time. So we need to look at the volume of requests and judging that, factoring in latency of the different platforms. What is, again, in a vacuum, what is the perfect number that we could even possibly attain with a user with no connection problems based upon the request size and the request volume that we're looking at? Third thing, we want to optimize the nature of any requests. We don't want synchronous tags loading on the website unless it is absolutely necessary for the function of that platform. The less things that have the potential of being a one-man blocker of different content and other items on the web page, we want to take out any of those potential factors. So looking at the request type, are they loading synchronously? Are they loading asynchronously? If it is synchronously, we need to hold them to a higher standard. We need to really analyze what that function is and look at what the latency figures are for that platform. Number of tags is another thing that we can optimize. Generally one, just cleaning it up. Again, if we remove the potential for any issues to be there, we don't have to worry about it. So if we can optimize and remove any tags that are maybe piggybacking in or loading in a whole lot of other third-party platforms, causing additional requests, causing additional issues where issues potentially could arise, we can optimize that. And then also the location and order. And that goes back to that point I was just making about data loss. So we want to be able to optimize the order of tag load, optimize the location of where those different tags are deployed in order to be able to minimize any instances of data loss in those different key platforms. So that goes through performance overview. Next, I want to get into some of those different findings from the Internet Retailer 1000. So just to summarize some of these different results, and first, I guess, to explain how we did this. So we ran tag inspector scans of, I believe, 1,000 pages for each, or up to 1,000 pages for each, across the full list of the Internet Retailer 1000 websites. So the top 1,000 in terms of traffic, e-commerce retailer websites globally. What we're able to collect when scanning is all tag requests, all tag behavior that happens on the initial page load, as well as page information and some timing information from the browser. So thinking back about those different metrics that we're really looking to optimize, pulled out some of those findings to see, where do the top websites globally that their function is to make money, where do they stand? What sort of what baseline do they set? And then also to be able to identify where are some of the issues where they can improve. So those are probably going to be the common issues that you, or if you are someone that works at one of these Internet Retailer 1000 sites, somewhere to really you might want to check first. So first thing we looked at was just page information. So page size, on average page size across all pages of these different sites, a little over 2,000 kilobytes. Now, not bad at all. One thing that a lot of people are starting to look at, and what I referenced earlier, is looking at the bandwidth that a typical user has. And different sites, based upon their audience, are going to have different users using different devices, accessing the internet, or accessing their site in different ways. So that's one thing that goes back to analytics and how we can tie in our web analytics to our tag management and optimization. Figure out who your users are. Figure out what types of devices they're using, where they are, what types of connection speeds it looks like they're using, and optimize the website, the tagging for that. So with a web page, for example, that's being accessed on a mobile device, even if it's a pretty good, solid mobile connection, so say like a LTE, 3G, 4G, that sort of connection. In order for that web page, again, just in a vacuum, in order for it to load right around 5 seconds, the general size of a page needs to be right around 1,000 kilobytes. Now, looking at Internet Retailer 1000 scans here, the average page size being almost a little over 2 times that, with a larger number of users beginning to access e-commerce sites and retail sites via a mobile device and on a mobile connection, we're talking about page load times estimated around 10 seconds based solely on the page size. And that's if everything else goes right. You have no synchronous loading tags. You don't run into any issues with resources and concurrent connections or anything with the browser. We're talking about almost 10 seconds. That's not going to cut it. So if you're trying to optimize for an individual situation like that, know your audience, know what you're shooting for, know where you stand right now. The next thing we can really look at is the total number of just requests. So average number of total requests being made by an individual or each of these sites on average is around 137. Now that includes images, that includes requests to the content delivery network for content, that includes requests for all the different tags. So this matters again because browsers have a limited capacity for how many requests can be outstanding at one individual time and how many they can process concurrently. So looking at 137 requests, if a browser can handle 17 concurrently, say latency gets all the way up to 50 Typically, people will set a limit of around between 300 and 500 milliseconds. Thinking about that, if every single request is taking around 300 milliseconds and you've got 137 that need to go off, again, that's not going to cut it. You're looking at slow page load times, even though everything's asynchronous, for the sole reason that just the volume of requests. So we want to reduce that. We want to look at the tags that are maybe the worst offenders, which ones are piggybacking in and loading in other tags that's really blowing up that number. Getting further into the findings, looking at the actual tag information itself, average size of a tag was around 14 kilobytes. Average latency, 25 milliseconds. Now that's also factoring in, to be fair, tags and requests that are cached. So latency in that sort of a scenario, because nothing needs to be loaded in, it's already there and available, is going to be 0 milliseconds. So that's going to deflate that number a little bit, but still on your website, something you want to look at. And then total tags on average, 27. Now think about that. You have a tag on your website for the purpose of it corresponds to some platform that you're using, some marketing or advertising technology that you're running on your website in order to do something, one on the site, maybe you offer recommendations for other products in order to collect information for remarketing, retargeting, content personalization, analytics, you name it. 27 different tags would mean that on average, 27 different advertising marketing technology platforms would be being used by a site. Now, from experience working with a lot of these e-commerce sites, a lot of people are not using 27 different platforms for advertising and marketing. A lot of this is, one, tags that are being loaded in or piggybacked that, again, need to be addressed. And two, situations where you have legacy platforms, legacy tags that are still there. Maybe you have conversion tags out there for a media campaign that you were still running with your old ad agency last year. That factors into that. Now, think about, just in general, thinking about around 27 total tags, average size of 14 kilobytes. Say a couple of the average request size, of 14 kilobytes, total tags, 27. So some of those are making 2, 3, 4 requests, so around 50 requests. You're looking at 700 kilobytes being added in for your page size solely due to the tags that are on there. It's almost a third of overall page size due to tags. If we can optimize and bring down that number just by cleaning up some of the legacy tags on our website, we're immediately dropping down that page size number and immediately then being able to at least give ourselves a chance to have good overall page performance and user experience. This is one other thing. We plotted a lot of these results. We plotted 2 different metrics here. Average total request count, so the total number of requests on a web page. We plotted it against average time to DOM complete. Now you can see here the general trend, right? That's what we're looking for. Just as the number of total requests on a web page increase, so too does the average time to DOM complete on a website. So too does that increase. So if we can optimize for that volume of the requests and keep in mind that that's not the only thing, other factors that we can optimize for there as well. If we can do all those things in conjunction, we can really make a difference through better tag management on the overall performance and user experience on our website, and also have other implications for things like data collection, analytics, and the reliability, effectiveness, and confidence in a lot of those platforms that you're really investing a lot in. So now that we understand how this whole process works, we understand some of the low-hanging fruit, just trends that we have identified from the Internet Retailer 1000 websites. How do we address it? How do we optimize? How do we actually get better here? So number one, general tag cleanup. figure out and identify all the different tags that are loading on your website. You can easily make a report like this just running a tag inspector scan. Identify the different tags, the different platforms that are loading, figure out which ones are legacy tags, figure out which ones are loading in a lot of different third parties, and get to removing them. In a lot of cases, it might be something that you are managing through your tag management system. Easily remove. Boom, you've already decreased the volume of requests. You've already decreased that page size. And something simple as just getting rid of legacy tags, things that are no longer in use. Next thing, we can optimize page size. So one, like I mentioned before when we were actually going through the findings, consider the connection speed of users. What is the optimal number for page size, or the upper end of that number for page size, just to give yourself a chance to give your users an expected experience on the website? So identify that maximum size of the page, and then all the resources. Think about all the resources that are going into that page and how you need to cap or limit each in order to be able to reach that goal. One website that's out there, performancebudget.io, which is a quick performance budget calculator. A guy named Jonathan Fielding created it. Great tool, at least to see some of these things just at that high level and see what that budget is. So you can put in, I want my page to load in X number of seconds on this type of connection. It's going to give you what is that maximum page size that you should be shooting for. Thinking about that, again, we can then look at the tags that are loading on the site, evaluate the size of all the different tags on those page, and then on each of those pages, just think, are there too many resources that are being loaded? Do I need all these different platforms for this type of experience? Or on my website, can I maybe use a different vendor that's not using the same number of resources from the browser or from the connection bandwidth perspective? Tag size. This is just a look at an export from one of those tag inspector scans where you can see the requests in there on the far right side. You can see the actual tag size of each of these different requests. So how many kilobytes is each request and what type of resources is necessary. So this is how you would go about actually collecting that information. Next thing that we can optimize, as mentioned previously, request volume. And this moves the needle because of those browser limitations for concurrent connections. Look at the number of total requests on the page. How many of those total requests are from tags? Is tag latency potentially a factor when you're overlaying that with just the general request volume? Also, look for any tags that are making a whole lot of requests on a page. Is it necessary? How large are those? What's the latency of each of those? I know some tags out there are architected in such a way to send a larger volume of requests of much smaller requests. That's fine, but know the behavior of those different tags. Know the behavior of all the different tags. What's going to be necessary, even when you're looking at a new platform to be deploying on the website, new tags to be deploying on the website. What is that cost going to be? And also here, really important, looking at piggybacking. So even if it's not a request from that one specific tool, if it is a tag that's loading in or piggybacking in other tags, that is also leading up to that budget number. Here we can see, again, from a tag inspector export, all the different requests sent by all the different tags on this specific URL. We can see the latency of each by factoring that together, total latency of all the different requests on a particular page. We can see and we can evaluate, again, is it even possible for me to meet my user expectation of performance of this web page? And also, which leads into our next point, location. If we're seeing that our analytics platform or some other critical platform, say it's my media tagging or my campaign tagging or my floodlights, if they're being deployed way down deep into a page, a whole lot of lines down, there's a lot of other tags, a lot of other resources, a lot of other things scripts being loaded before them, it's going to lead to issues with data loss as well as the deprioritization of those different tags. So look at tag depth, look at latency, look at the number of requests, and look at where they are in relation to each other. We can see that again in the tag inspector reports here, just for line number and then total lines on a page, so we can get that depth figure. But think about priority of the platforms that you're using. Think about which ones need and which ones your team and organization really needs to see data in, really need to work. Obviously, you're investing in everything. You want everything to work. But in the event of something going wrong, what is most critical? Factor in that for location of the actual deployment. So that is everything that we wanted to cover today. Obviously, we went through just a general performance overview. How exactly does the web page, how does the site work? How do tags play into that? What are some different areas of optimization that can be taken from findings that we had from scans across the Internet Retailer 1000? What are some of those areas of low-hanging fruit? And then how to address each and optimize for your website. So what I would encourage is go through, start with just a general tag inventory, understand what's on the website. Get rid of anything that's legacy, get rid of anything that's really not in use in order to be able to automatically, before even going into an in-depth analysis, really optimize just the number of requests, size of the request, page size. It's all going to have a positive effect just by getting rid of stuff that you're not using. From there, really go through and identify, how many requests, where are my users accessing my site from, what types of devices are being used, what does a connection probably look like, figure out that budget for how large, page size, if depending upon the browser type typically used to access your website. You start looking at number of concurrent connections and then factoring those things together. In a perfect scenario, what does overall page load time on your site look like? Does it need to be optimized? Where can you optimize? Is it something where we can reduce the size of certain requests, that we can just reduce the volume? What is it? Optimize to that point, and then finally look at location and prioritization of where your tags are loading within the web pages themselves. So with that, we will turn it over to any questions that anyone has. Let me hop into the pane here. And it doesn't look like I'm not seeing any, which is fine. If anything pops up, please don't hesitate. Shoot us an email, give me a call. Let me know what questions you have, anything that you want to maybe look at on your site specifically. We're happy to help with any of those items. We'll be back in 2 weeks where I'll be going through some of these same items, but actually more of a training webinar on Tag Inspector, the tool itself. We'll go through the reporting, how exactly we can get to these data points, how we can extract these things, and then get on the process of actual optimization. So thank you everyone for joining again. Be on the lookout for those next webinars, and I look forward to seeing you on here again soon. Thanks.